So what's the best way to measure the presence of the virus anyway? Let's check with Nist. Nist. Capital N, capital I, capital S, capital T. Nist. This acronym stands for National Institute of Standards and Technology. Nist is an institution in the United States federal government, and it's based in Maryland, conveniently right outside Washington, D.C. It might as well be because all of those federal organizations tend to be centered around D.C. And its purpose is to really be a leader in the United States in metrology, or the science of measuring things. It sets standard measurements. It recommends to business and industry, as well as other governments and universities, how to measure things that are important. Why in the world would you even care about something like that? Well, in the words, paraphrased, of one of my mechanical engineering professors several years ago, he would say, if you can't measure it, you don't know if you made it better or not. Meaning, if you were going to design something or redesign something, how in the world are you going to define whether or not you made a better product unless you know how to measure if your product is really better or not? Way back in the history of the United States, George Washington sort of knew this, although he was talking more about money. Back when gold and the weights of gold were actually really important for setting the value of our currency, Washington really recommended the importance of accurate weights and measures so that business could be done and you could trust that this amount of gold is the amount of gold that you said it was. Now, fast forwarding many years, Theodore Roosevelt appointed a director of the National Bureau of Standards in 1901. And that bureau was built on the idea of having accurate measures for things, beyond stuff for money, but also just to produce any kind of technological innovation. So back then in 1901, the Bureau was recommending ways to measure the quality of clothes, or how to manufacture parts for cars. And pretty soon in World War I, the Bureau was getting involved in standard measurements for manufacturing of military-related equipment. And so the words of my mechanical engineering professor really rang true even in history. We needed to measure the quality of different products, and you can measure quality so many different ways. Why not have one way that everyone uses, or several ways that everyone agrees to use to measure that quality? Personally, I first learned about Nist not in engineering school, oddly enough, but when I started working as an engineer finally. And I met a coworker who came from Maryland, and he worked at Nist for a little while. And you can imagine some of the stuff he was doing. It didn't sound interesting to me at first, but now when I'm older and wiser, you understand the importance of measurements that everyone can agree upon. One of the things we had to measure was, for example, the roughness of medical implants that would go inside the body. Think about that. We actually had to measure the roughness of the stuff we were putting in people, because turns out you need a certain roughness of a surface so that bone will grow into it, or that blood will adhere to it, or maybe a certain roughness so that bacteria won't adhere to it. Or you need a certain amount of roughness so you get a certain amount of friction so that liquids will flow over it, or it can be sterilized properly. Roughness is an important characteristic of medical implants. Now, how do you measure quote-unquote roughness? Think about that. How would you measure roughness? It's not just friction. Maybe you have to measure the porosity of the surface. Maybe you got to take a little stylus and run it along the profile of the surface and make a little graph of the peaks and valleys along that surface. That's kind of what my coworker had worked on for a little bit, and what we had to look at when I was first working as an engineer, making medical implants with just the right kind of roughness, as defined by Nist and measured by us. And the recommendations of Nist go way beyond medical implants and beyond the quality of cars and clothes. I mean, today they're involved in election security standards and cybersecurity and creating tests to really qualify or certify if a voting system is valid and secure or not. They were involved in making sure our votes were accessible to people with disabilities. For COVID-19, they helped define the way to measure the viral load in our swab tests. You know, those cotton swabs that get shoved up our sinuses? Well, Nist helped define how we're going to measure the amount of viral RNA on that swab. Maybe defining mathematical methods for interpreting the data from these swabs. Maybe defining algorithms for machine learning in analyzing the presence of COVID-19 in different places. Nist knows that how you measure something is so important, especially when you have so many engineers out there and scientists and accountants and whatever measuring things in potentially different ways. They know the importance of choosing a single way that we can all agree upon. And that is why Nist is our engineering word of the day. Thank you for listening to the Engineering Word of the Day podcast, even if today's word was an acronym. In these strange times, I hope you're staying safe and doing what's right and good. If you got time outside of that, you should listen to my longer podcast, the K-12 Engineering Education Podcast. Find out more at k12engineering.net.